Hello there and welcome to this concise introduction to logarithms. Now, this statement here that I have, this says that 10 squared is equal to 100. Or, in technical terms, the base 10 raised to the power 2 gives 100. Now, to put that into a logarithmic form, I'll have to rearrange what I've just said and rearrange this little equation here. To put it into a logarithmic form, you could say the power to which the base 10 must be raised to give 100 is 2. In this form, the power is called a logarithm. Now, log base 10. You have the log of base 10. Log base 10 100 is equal to 2. Now, these and these are identical, it's just that the numbers have been shifted around a bit, and you have this log 10. Log base 10 is normally abbreviated. If you see just log on its own, it's assumed to be log 10. But for this case I'll put a base. And basically the base 10 just means by what exponent do you raise the power, do you raise 10 to get 100? And it's 2. You raise the base of 10 to the power of 2. And logarithms are neat little things. Firstly, they allow us to, if you have, for instance, b equal to a to the power of c, this implies and is implied by log a of b which equals c. And logarithms can also help us turn maybe tricky multiplications into additions. You have log b c equal to log b plus log c, and it works both ways. It also allows us to turn a sum that would normally be a division into a subtraction. Log b over c is equal to log b minus log c. And lastly, the last law of the logarithm is the log of b raised to some power n is equal to n log b. Now, logarithms are used when you have exponents, and they're used for many things, to find, for instance, when two lines cross, or to calculate the growth of some function. They're very useful, and for now we'll stick to the simple stuff and we'll use the rules, and I'll just demonstrate a few things. Express log p squared r, express log p squared r in terms of log p and log r, sorry. Now you can skip ahead and do this for yourself, or you can watch this walkthrough. Now, log p squared r. Don't be put off by the exponent, but this is equal to log p squared plus log r. Now you may think that's done, but you have the square of p. You need it in terms of log p. You need it in terms of p on its own. So using log bn is equal to n log b, that then becomes 2 log p plus log r. And there you go. You've just changed it into an addition, and then you've brought the power down, and now you have log p squared r in terms of log p and log r. Let's move on to an addition. Let's do log q over r squared, expressed in terms of log q and log r. Again, you can skip ahead, but this is simply just using this rule here. Log q over r squared is equal to log q. The numerator is always the first one that you subtract the denominator from the numerator when you open up this division when using logs. It's not log r minus log q, it's always the top minus the bottom. Log q minus log r squared. Again, you've got the square of r and you need it in terms of just r. So using log bn is equal to n log b, have log q minus 2 log r. And that's that. Now, we could have more than one indice here. Let's say for instance we have log p to the power of n multiplied by log q to the power of m. This is equal to log p to the power of n plus log q to the power of m. Again, this is not in terms of log p and log q because they're raised to some power n and some power m. We don't know them and we don't need to know them because we've got this law here, that log b to the power of n is equal to n log b. So that is equal to n log p plus m log q, and that is it. This is your short introduction to logarithms. If you've got any queries or questions, message me or comment below and I'll get back to you as soon as I can. Also later I will try to upload some past paper questions so you'll actually have a context in which we'll use logarithms. Thanks for watching.